Astronomer, just a few offices away from me on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh, and that is Marley. Hey, Marley, how's it going?
It's fine. Could you imagine if I wasn't trusted? Like that. Like, I think about that every time you say that. I'm like, what if I was not trusted?
Well, I'm sure that there are some untrusted astronomers out there somewhere, right?
I won't
So
name any names, but maybe.
for another episode, the untrusted astronomers in the universe.
Mhm.
But of course, you being our trusted astronomer, we have got some news, some updates, of course. Artemis is going to be splashing down. I think it is scheduled to splash down on Sunday, I believe. So it's been doing these really long, interesting orbits, and it's actually been really fun here at the Space Center. I've been jumping in and doing a lot of shows, and it's funny how like almost every show we're able to tie in something to do with Artemis. Whether it's talking about astronauts living on the space station, to Rocket Lab, to exploring the solar system. Artemis is in there everywhere. It's an exciting time for human exploration, and kids are excited about that possibility. So let's get into our big topic, all about Artemis updates. If you are watching on YouTube or Facebook or Telesoptic, come on in and ask some questions. You can ask any questions under the universe. We will get to them before the end of the show, but we'll answer the ones about Artemis first if you have any curiosities. So Marley, what is going on with Artemis?
The Artemis mission well underway now. So as you said, the Orion capsule is scheduled to splash down not on Sunday, but on December 11th. So I think just the next Sunday after the one that's coming up, December 11th, it will splash back down into the Pacific Ocean. And actually, just literally 10 minutes ago, it completed its deorbital burn. So right now it's been in a distant retrograde orbit around the moon, right? Collecting these actually beautiful images. I was kind of surprised at how beautiful these images are. The one on the lower right-hand side of the screen is like an up close, of the lunar surface, which is just a fantastic image brought back. And then of course the images with Orion, with Earth in the distance and stuff like that. Just really great photos. But 10 minutes ago, it completed its burn to leave that distant retrograde orbit around the moon. So it's been there since November 25th in that type of orbit. And it conducted the burn today successfully and is now started its trek back home. So it'll splash down December 11th is when they're sometime December 11th. And then it'll be retrieved by the United States Navy and sent back to NASA for testing to learning what went on with Orion and what happened to those moonikins that are inside, those horrible torsos that freak me out.
Right. So there's a lot going on, with this mission. Of course, it's Artemis 1. So it is a test. It is the precursor to the human missions to come next. But of course, inside of this mission, there's a whole bunch of things going on in terms of the capsules. Like you said, the Orion capsule. There was also CubeSATs attached to these. So there's all these other missions that went along with it. And then, of course, there's the return. So for the most part, everything's been successful. There have been some things that have been maybe not as successful. Of course, on Sunday, we'll hopefully see a successful return. But maybe just like break down some of all of the parts of what we're talking about with Artemis.
Well, the part that I wanted to focus on today mainly was the CubeSats because those
Yeah.
were very exciting. The CubeSats of Artemis 1, like it was kind of overshadowed by the entirety of the Artemis mission, right? These very interesting science experiments were going up, but they were hitching a ride on a rocket that had never been launched before. So it's kind of understandable that they would maybe be forgotten a little bit. But I wanted to talk about them because there's been some interesting and also some sad developments with them. So there were 10 originally CubeSats who were ride sharing on board the SLS, and they came from a variety of places, but where they were in terms of launching, we didn't see them is because they were hidden away in this part of the SLS called the Orion Stage Adapter. So when the rocket is built, all of these different pieces are put together, right? It's called stacking. They're stacked on top one after the other to get all of these parts done. And so the CubeSats were actually sitting in this tiny spot, the Orion Stage Adapter. And there were 10 of them. Originally, there was going to be 13, but 3 of them missed the integration deadline when they could be put in to the Orion Stage Adapter. And so they were left out. And so we had 10 CubeSats all loaded in. So this is an image from where they were being installed into that Orion stage adapter. And then that was stacked on top of that large core stage of the rocket. And then the Orion capsule and all of its little pieces went on top of that. So that's where they were kind of hidden away inside. 10 of them, the 10 that did make it, were loaded onto the Space Launch System as of October 4th, 2021. 9 of them were loaded up prior to that. The last one to load was a CubeSat known as, I'm going to mispronounce, Biocentennial, I think was what it is. It was loaded last because it contains live organisms. It has yeast as part of its experiment. So it was loaded last because they wanted to try to leave it to like the last possible second, right? To keep the yeast as stable as possible for their experiment. It was actually refrigerated prior to be putting inside to keep that yeast from developing and the living organisms, like keeping them preserved for as long as possible.
So was this kind of like, at the beginning of the pandemic, how everyone was like really into like making bread and making sourdough? Were the NASA engineers like, let's send some of this yeast and bread up to space, see what happens? What's going on here?
It has to do, I can jump to the Biocentennial slide. So Sentinel, Biosentinel. It's the CubeSat's the size of a cereal box, but its experiment is to see what deep space radiation, the impact it'll have on DNA, right? So, we have our astronauts on the International Space Station, and, they get some radiation from being on the International Space Station, but they're still within the Earth's magnetic field, which helps shield the crew from any of that deep space radiation. So they're pretty okay. But on longer journeys, like when we want to send human beings to Mars, we will have to deal with this deep space radiation and its damage upon DNA. And so Biosentinel is that test. So it's testing using yeast, right, which is what they consider a model organism. So it's something that models what will happen to us very well. And it's easily manipulated and easily studied, right? And we know how it works very, very well. It works really well for this case. So both human cells and yeast cells, in both of them, high energy radiation can break the DNA and cause that damage. And over time, DNA damage can be repaired by a process in cells that is similar between yeast and human beings. So even the process, not just the cells themselves and the damage they get from the radiation, but the process that the cells use to fix themselves is very similar between yeast and human being cells, which is weird. We are more like bread, I guess, than we think. Shout out to my Italian family. Good news for them.
Well, and me as well, because I'm like a huge bread fan. Anyone that knows me, it's basically all I eat every day. So I'm a big fan of Biosentinel missions here.
Something about the carbs, but yeah, bread is good. But this Biosentinel will not be making bread. Instead, it's going to put a bunch of yeast into deep space and have it be hit with a bunch of deep space radiation and see what happens. See how it reacts, how the experiments cope with it, because they're using 2 different strands and strains of yeast. They're using one that commonly found in nature, and the other one was picked specifically because it has trouble repairing its DNA. So it kind of acts as kind of a control, right? You have one that may either repair it very well or not repair it at all. And then you have one that we know has a hard time repairing its DNA, right? So hitting it with radiation, if it has a hard time repairing its DNA, will for sure show us that it's been hit with radiation and something happened to it. Whereas if they're both good at fixing themselves, we never really know. So it's a very interesting experiment. And you'll see on this slide, I have the last thing, it says working. And that's very important because some of these CubeSats are not working at all. And that's kind of the sad part about these CubeSat missions that I wanted to get into, is that some of them, despite being these really great and interesting experiments, have not been able to work out so far.
Okay, well, let's go an overview here and go through some of these and maybe give a shout out to some of the ones that might not make it.
So there were 10 in total, right? 4 of them dealt with lunar missions. So like Lunar Ice Cube, Luna HMAP, Omotenashi, Luna IR were all lunar missions. One deals with the sun, CUSP. One deals with asteroids, NEA Scout. One dealt with Earth. I cannot pronounce Equilis. That's a very acronym, too many vowels for me. 3 just dealt with other stuff. So Biosentinel being one of them, one called Argo Moon, and one just called Team Miles. And you'll see that some of them have a little asterisk beside them, and one of them is in red. So the asterisks are ones that have encountered problems, or we don't have any information on them, or I haven't been able to find any information on them.
Mhm.
So after launch, 6 out of the 10 were able to phone home, quote unquote, right? So when they leave, when the rocket is launched and the Orion stage then leaves the interim cryogenic propulsion stage, what the computers in here tell the CubeSATs to leave the Orion stage adapter. And the Orion stage adapter and its computer system in the ICPS all said they all left. All 10 made it out. But what they're supposed to do is they're supposed to then phone home and be like, hey, I made it out, kind of confirm. And not
Mhm.
all of them did that within after it separated, right? So at first we weren't sure where some of them were. Eventually they then started to phone home and a couple of them came back. But that just because they phone home does not mean that they are working properly. So there are a few of them that are not working at all, as I go down in my notes to explain exactly which ones. But it's the Luna HMAP, Omotenashi, Lunar, T-Miles, and NEA Scout are all ones that are either not working at all, we don't have information on, or in one of them, they've been deemed mission failure, and then another one just not working as well as we had hoped. So the one that was deemed a mission failure was Omotenashi in red there. And for reasons I'll explain why. But as I was looking at all of these CubeSats, I was like, why did so many of them not work as well? Right. And then I looked at the timeline of the Artemis mission, and that kind of gave me a clue.
So,
This.
so you mean it wasn't because they didn't have a speak and spell that was attached to them? That was an
No.
ET reference, by the way.
Oh yeah, sure. I don't know, Michael. I'm like 25. I haven't watched ET in 1,000 years. No, this is a ignore this little box there. But looking at the timeline for these CubeSats, they were all loaded into the Orion stage adapter and stacked in early October 2021. Right. And then we didn't launch Artemis 1 until November 15th, 2022. So they were inside of this rocket for a full calendar year, just sitting. And in between that time, you have, delays upon rollbacks and all of these problems. And from what I could find in reading like the NASA blog that they put out and trying to find information off of the different companies and agencies that develop these CubeSats, is that they were batteries ever only recharged once. And that's what this little square was supposed to say. It was only ever recharged once back in September, October-ish of 2022 is when they were recharged. But in reading about them, they never say exactly which ones are recharged, but they do say that not all of them were recharged. Only some of them got their batteries recharged. And that could explain perhaps some of the reasons why a couple of them we haven't heard back from and don't know what's going on with them because of this very long delay. I don't think they meant for them to sit inside of this rocket for a calendar year, being only recharged once.
So it must have been so lonely just sitting up there, just waiting a whole year for the launch to happen.
Well, they're not alive, but I think, at least they didn't have to deal with the impatience that I felt waiting for this launch to happen. But regardless, we now have some working, some not. So that might not be a total reason, but I do find it interesting that they won't announce which ones got their batteries recharged. And it wasn't like, I know it wasn't a thing of, oh, this experiment's more important. It was more of an access issue because when it's all stacked on top of each other, what they don't want to do is take the Orion capsule off the top, right, and move everything back because this is all stacked together. What they don't want is to take the Orion crew vehicle off, get back in there and plug them all in, right? They can access certain ones and they can't access others. Some CubeSats may not have even had a chargeability, like a charging possibility for them, right? So it kind of becomes maybe some just couldn't, but also please tell me which ones. And then maybe I will be less concerned about why they are not working. But
yeah, so it's almost like when they were designing the CubeSats, they must have had some sort of contingency to be like, well, we could have added like these chargers if we knew that it was going to be delayed this long. But that would, of course, maybe have added more costs, and maybe that, there's all these factors that come into play when dealing with this. But the big picture is that this was the first launch of this brand new vehicle. So there was probably to be expected a lot of things to kind of go wrong. So for still half of the CubeSats to survive, that still seems like pretty good to me.
No, it's still good. It's just like I kind of expected better, but I don't know. It's still very disappointing, especially because some of the missions would have been so interesting. The ones that failed, specifically the one out of JAXA, which is the Omotenashi mission. I was very excited for when I heard this CubeSat was going up, because it's a CubeSat that had its own payload. So the CubeSat itself is a payload on board Artemis, but it itself is carrying its own payload, and it was to be a lunar lander, and the smallest lunar lander, ever put on the moon. It was very, very tiny. I think it weighed only a kilogram, the lander itself. But this mission, it has been declared mission end, mission failure by the Japanese Space Agency through many, and they're not too sure why. They have started a reconnaissance team to try to find it. So what happened to it is that it successfully separated. Omotenashi did phone home, to quote ET reference, I guess. It did contact us on Earth, but the communications were very unstable, which is not a good sign. The information that came back said that it was tumbling, which means exactly what you think, like it's spinning around, it's not oriented right. And JAXA did try to stabilize it, stabilize the attitude, so the spinning, the power, right, for its solar panels to be able to actually face the sun and establish communication with the spacecraft, but they were unsuccessful. It did not work. And so they kept trying to get in contact with it. But it missed its window to land the lander. So there was a specific point in time when it was supposed to receive a command to initiate the landing sequence for the lander, and it was supposed to radio back, hey, I've done XYZ. It missed the window to communicate. They did not hear from it, whether or not that had happened. And eventually recovery attempts were abandoned on November 22nd. And now they're investigating what went wrong, what could have gone wrong. And most likely they think it was due to after separation, when it left the Orion adapter, the side with the solar cells was not facing the sun, and so the batteries could not charge. And so that's why you would get that weak signal, and why you would lead to not being able to send or receive any signal. And so now they're moving on. The lander's a failure, right? It's not going to land, but now they're working to recover the probe itself as more of a tech demonstration, right? So we can still learn from what went wrong with this and work to develop a better CubeSat in the future.
So are you saying that they don't know where it is, but it's most likely that it's not on the moon, but it's in somewhere in like some orbit?
Yeah, it's most likely in some lunar orbit, but the lander that was supposed to come out, this is like a computer generated image from JAXA. This lander thing they don't think ever separated. It's still all attached.
Okay.
And just somewhere in lunar space.
Okay. And how are they going to attempt to recover it?
They've organized a team, and that's as far as I've gotten in reading their press releases. That's as far as I've seen. They've organized a team, but they still have another one that's working fine. The Aqueous one is also a JAXA mission, and that is still, it's working perfectly fine. So they still have, something else to look at, where some of these other teams kind of have nothing. It was a one and done thing.
Okay, well, this is interesting. We're actually working on potentially doing a Japanese event next year in July for their annual star celebration that happens in July. So maybe we can find some ties into some of these Japanese missions, because they're small, but there's some really cool things that are happening, especially that I can't remember the mission to Itokawa, the asteroid Itokawa that came by. That returned a piece of that asteroid a couple of years ago.
Oh yes, was that the Hayabusa 2 mission?
Yeah.
Great mission.
So lots of great stuff from a variety of space agencies, and even it was announced even a couple weeks ago, was it, that Canada is going to land a rover on the moon as well. So for that kind of a mission, that's not a CubeSat. So this particular mission, because I'd never heard of CubeSats, also deploying, mini rovers themselves.
Right.
Is this something that Artemis 2, like the next iterations of Artemis, are they also going to have CubeSats attached to them?
I do not know, because I feel like this one, it was fine to do because there are going to be no people on it. And I feel like once you introduce people to the situation, you start to want to just focus on everything going right with them. They might, they'd still fit in that little spot, but I haven't looked into whether or not the CubeSats will be included.
Right. And then, of course, like anyone that is spending money to put it on, or maybe thinking that it's not very reliable, just depending on the percentage of them surviving.
Well, it's a risk, right? You take, I don't think anyone anticipated to be on the rocket for that long. And so maybe anticipate that next time. I don't know, you have to learn from right. What happened, because sometimes, life just throws you curveballs. No one knew the hurricane would show up,
Well, it wasn't just the hurricane. There was many other factors at play
Oh,
as
yeah,
well.
yeah. But then
But
just to top it all off, yeah, a hurricane. But you do.
wonderful. Well, if you're out there watching on YouTube or Facebook and you have any questions about any of these CubeSats, get in here and ask some questions. We've got about 10 more minutes. Let's go over a few more of these missions before we end the show.
Yeah, so this is another one that I'm very interested to see what happens with it. It's another one that's not working, which is why I'm so interested to see what ends up happening if they're able to find it. The NEA Scouts. This is the Near Earth Asteroid Scout mission, and its target is an asteroid called 2020 GE, which is a near Earth asteroid. No need to worry about it though. But it's interesting because it's was going to go learn about this asteroid, but it was also demonstrating a new solar sail technology, so a new way of moving around space without using fuel propulsion. So when released, the idea was that it would extend this large solar sail, right? That's thinner than a human hair, right? So very, very thin sail made out of aluminum and coated in a plastic. And it would generate thrust by reflecting photons from the sun. So these photons would hit the solar sail, bounce off, and that little bouncing off movement and that reflection would generate thrust, would generate energy that would push the sail and push the spacecraft where it needed to go. Oh dear, no more almost gosh, so sorry. And push it where it needed to go. The sail would provide most of the thrust necessary, most of the propulsion necessary for this CubeSat, but it would also have small cold gas thrusters that would assist with more finer maneuvering, especially once it approached the asteroid and things like that. And the sail was very big. The sail's like a third the size of a tennis court, so a decently large thing packed into it. Tragically, I guess, no signal has been obtained as far as when I was looking into it yesterday, and I think also as of this morning. No signal was ever obtained, even on November 16th, early in the morning after it launched, after everything separated, and it was radioed that it had left the ICPS. It never, the team could never get in contact with it. It never dinged itself back and said, hey, I actually made it out. And they've been trying as of November 18th. They still haven't heard anything. On November 21st, I think it was, the team sent up a command for it to open its solar sail early. So it wasn't supposed to open its solar sail until December, early-ish, I guess this month, early-ish December. They told it to open its solar sail early. They sent the command up twice, never heard back. But the idea was, okay, if it can open up its solar sail, it'll reflect that sunlight, the photons from the sun, and maybe someone in an observatory somewhere will see it in the sky.
Right.
But no one spotted it to date. I was looking at, because how they communicate with the spacecraft is through the Deep Space Network, right? With those, 3 locations, one in the United States, one in Australia, and one in Spain. And they are these, huge locations that communicate with all of our spacecraft. They've been using it to communicate with all these CubeSats as well. I did see that they were trying to establish a link, they were sending an uplink signal to NEA Scout, but I didn't see if anything ever came back. So They were still trying to talk to it as of yesterday, but nothing official has come out about it.
Oh, that's so sad, because this is obviously missions, anything to do with asteroid defense have been a big part of let's say the Planetary Society, their big mission, and obviously something that directly affects humans. But sadly, it hasn't been a ton of asteroid missions. We saw one recently with DART, but this one was certainly going to be a good test. And also, speaking of the Planetary Society, their solar sail just came down a few weeks ago as well, Light Sail 2. Solar sails, very cool technology as well. I would have loved to have seen this one work. Hopefully we'll see more of these. Before we move on to another one, we just do have a question, which I think a good question from Fair Marino. So the pre-launch idle time that affected a lot of these instruments, could parts or instruments on the JWST have a similar problem because it also had multiple delays, or is that no longer a risk anymore?
Ooh, that's a very good question. Yes, so JWST had so many delays. But what's interesting about JWST is that it was a specific part before it was combined, right? So we had delays with the mirror unfolding itself. We had delays with the sun shield, unfolding itself. But once it was integrated, it worked a bit better, and then it got disassembled and shipped off to where it was launched from, and it was okay. But it was with the initial building that a lot of those delays came out of out of for JWST. For the CubeSats, they are a bit different. I think kind of the main issue, if I were to point to a main issue with the CubeSats, it was the fact that they were isolated for so long, right? They were just left in this spot for so long, and when they might have been anticipated to launch much sooner, and having just sitting there already fully assembled led to a lot of the problems that could have happened, instead of them being put in and then launching right away. So I think it's still possible that the idle time did it, but kind of in different ways for the two of them. I don't expect Webb to have as many problems, because the main problems with Webb were when we were still building it. Once it was integrated, it was fine. For these, I don't think it's as much as a building issue as it was just a sitting on the launch pad issue.
Yeah. And probably for NASA, they were lower priority for the entire mission, right? They were just kind of like an add-on.
No, the priority was the rocket, and the Orion, not the CubeSats, which is whatever. But
Harry asks, what are some examples of successful signaling and commanding technologies in space?
Like an example of a successful CubeSat, I guess.
Perhaps,
yeah. So we have Argo Moon, very successful mission. This is from a company called Argotech, who also did Like a Cube on the DART mission, an Italian company sponsored by the Italian Space Agency. This one was able to call home right away. It had a stable connection. I guess if you're looking for an example of a successful connection, it's something that is stable. And if the spacecraft is tumbling, so if it's spinning like that, that means its solar arrays are not able to orient themselves properly to the sun. And so what you would do to fix that is send a command that says, fire your boosters like this way and such, and then stop tumbling, essentially, but more complicated than that. And then it stops, it obeys the command, it stops, it executes it properly, it does stop tumbling, it's able to collect a charge, and it's kind of a lot easier from there. A lot of the problem is like getting it to stop tumbling, I think also was a big problem with some of these CubeSats. But that would be like a successful thing, is if you are able to have a stable connection, get it oriented so it's able to charge its battery, and the health and safety data comes down saying that it's doing so, and it's now like a healthy spacecraft. So Argo Moon is an example of one of those. It was, along with the other CubeSats, its mission really was to actually take photos of the ICPS and the Orion module, like where those CubeSats were. And so this is the other question I have, is if this was supposed to take pictures of all the CubeSats, show me them, because I want to know if all of them actually made it out, like where are these anyways. But eventually I'll find them, or they'll release them. But in the meantime, they've released these absolutely wonderful photos of the Earth and the Moon as it's been going around. It's a very, very good spacecraft, I think, because it just has a very, very good camera. I think really it was just meant to take photos, and that's what it's been doing, and it's been doing very well. These are also photos from Argo Moon as well. I love them, just very close approaches and all. And then I think that's it for it. It'll just stop eventually, but a successful mission nonetheless.
Absolutely. Well, the last couple minutes, Marley, do you have anything quickly to mention about any of the other missions, or are those all the CubeSats?
Oh, I mean, I don't have any dedicated slides to any of them. The other one I guess I'm excited for that's been having a bit of trouble is the Luna H map. I'm excited for that. It's supposed to map the surface level hydrogen on the moon, which would be very, very cool. Kind of looking for water, what very exciting thing with the moon. But its problem is that it had a propulsion issue. So when it needed to enter into its proper orbit around the moon, when it fired its thrusters, it was not able to generate enough thrust. And so it missed its propulsion burn insertion. And so now it's on a different orbit around the moon, and they're trying to fix it. They think that it's just very cold and kind of frozen. So they're trying to heat it up somehow. But if they can't do that, I think one of the members of the team said that they would just maybe send it in the direction of an asteroid and hope for the best. And I was like, well, I guess imagine your backup being, oh, we'll just go to an asteroid. I thought that was quite funny, but hoping out for the rest of them. Hope we find the Near Earth Asteroid Scout. Really hope we find it.
Yeah, excellent. Well, that's about it for this edition of Ask an Astronomer. Thank you so much, Marley, for these updates. As always, we'll be back in 2 weeks for our last Ask an Astronomer of the year, which is going to be on December the 15th. But next Thursday, we also have our last evening in-person event of the year, and that is going to be Indigenous Astronomy with Shandon Pete, who was a previous Ask an Astronomer guest. So you can go back and watch our conversation with Shandine earlier this year. And next Thursday, we're going to do a really cool program. He's done a lot of research on looking at the night sky in different Indigenous cultures, a variety of them. He's going to tell us the perspectives and some of the research that he has done, because he is now at UBC. So you can find tickets to that event on our website, spacecenter.ca. And of course, we've got our last Ask an Astronomer. And then next year, we'll likely even be changing the time of Ask an Astronomer. So we're leaning towards maybe 4 p.m., 4:30 p.m. If you have thoughts on the new time for Ask an Astronomer, we'll be back. We'll likely still do Thursdays. But if you have any ideas, please, you can email them to me if you like. Programs@Space Center.
Yeah, don't email me. That's so funny. Sorry, Michael. That was hilarious. Yeah.
Well, I thought they could go somewhere. We might as well email them to me because, I'm the one that can dictate the schedule, right? So
Yeah, that is true. Michael does the schedule. Email Michael.
All right, folks. That's it for this edition of Ask an Astronomer. We'll see you in 2 weeks.